Hello, my name is Dmitry Orlov, Orlov. Some people know me under this name. And today I'm going to give you a lecture about introduction to the world of GDV Bioelectrography. Let's start. So let's start our lecture. Well, we'll have to start from the history. Well, because you know that if you are not learning history, you are doomed to repeated mistakes. So you have to know the history. And one of the main objectives here is that you will have to answer the questions of your potential clients or your potential users or just relatives and friends who will ask you what kind of education has you got, and if you have got a degree in bioelectrography, well, you should be able to explain that this is not something absolutely brand new that has just appeared on this planet. No, it has a pretty long history. And the history of GDV bioelectrography has begun more than 2 centuries ago. So the first name that we need to remember is George Lichtenberg from Germany. In 1777, he was making an experiment with the metal rod that was covered with the glass. And just when he was connecting the wire to this metal rod with his hand, touched it with the hand, he has noticed that there was some kind of emission or glow around his hand when he was touching the glass surface. So, well, this effect of fluorescence or glow he has registered, and then he made different types of experiments, not with the hands then, but with different type of conductive objects, showing that in the high intensity electromagnetic field, the glow appears of animate or inanimate, like living or non-living objects. They should be simply conductive. So these first pictures are known as Lichtenberg figures. So time passed by, and next name, very popular one century later, in the end of 19th century, Nikola Tesla was making experiments with electricity, and well, you know that he was the one who has made the alternative current possible. So this alternate current or alternating current has made it possible to make not only high intensity electromagnetic field, but also high frequency electromagnetic field. So while experimenting with these high intensity and high frequency electromagnetic fields, Nikola Tesla has shown that if a person stands near in such an environmental conditions with such a high electromagnetic field, the glow surrounds whole body. So, well, at those times, well, people were not able to understand and describe the nature of this glow. So there were many esoteric interpretations of this glow. So like it was some kind of aura or biofield or whatsoever. So in fact, not many people were eager to repeat experiments by Nikola Tesla. Well, you probably know that during this kind of glow, lots of ozone is being accumulated in the air, and it's not so healthy to breathe such saturated with ozone air. So not many people were eager to repeat it, but at least Nikola Tesla has shown that whole body can emit this kind of glow, and also different types of conductive objects. the most interesting for researchers and investigators were studies of the glow of living objects, of course, human beings and different plants, etc. So, in the next century, well, at the edge of the next century, Yakov Natkevich Yotko in Russia has also made experiments with high voltage generator, and he didn't simply watch this luminescence or this glow that George Lichtenberg and Nikola Tesla has seen, but he has learned how to capture this luminescence and this glow on a photographic plate. So as long as it was already some kind of image, a photo, so the term electrography has appeared. So it means that you can not only watch this, but also you can record the glow and then analyze it. So several years later, in Brazil, Father Landel de Moroa has created an electrographic camera. Well, it was pretty huge and pretty big equipment, and it was really complex and of course dangerous, because playing with high voltage and high intensity fields, high frequency fields, well, it's not so safe, specifically if you don't know the limits and conditions that are good for living beings like people around you. So, and the complexity and the fact that it's dangerous, well, prevented the method from becoming worldwide spread, but at least it was the device created for this kind of electrography. So several decades later, in 1933, a family of Simone and Valentina Kirlian in Russia, they have also registered, noticed the fluorescence of fingers while they were working with high frequency equipment in the hospital. So as long as the electrotherapy was pretty popular in those years, and this kind of therapy was prescribed to different patients in the clinics and hospitals. So it's just an accident that they have seen it, and they were curious. What is it? This kind of glow around the fingers. So, of course, they started doing their own experiments and their own research, and they were so really excited about this effect. They spent the rest of their lives doing these kind of experiments with high frequency photography. So they have published lots of papers. They have made lots of these kind of beautiful Kirlian photos. And just because of their enormous input into the development of this technology, now, even nowadays, this effect is known as Kirlian effect. And the photography is more commonly named as Kirlian photography. So what has happened next is that Professor Newton Milhomens in Brazil has built his first Kirlian camera that was photographing the glow of the fingers on the photographic film. So even though he has based his device on the Soviet electronic scheme, doesn't matter. Well, he was one of the first one to make a device that has become pretty popular and widespread. So even now in 21st century, devices by Newton Milhomens are still being produced and being sold in South America, and you can even buy them in other countries. So in 70s and 80s of the 20th century, worldwide, as long as the electronic equipment and all the components have become much more available to just engineers, electronics engineers, so they were able to buy them in the shop and then construct their own coil and their own Kirlian camera themselves. So there were lots of researchers and enthusiasts who were making their own Kirlian devices at their home or in their garage. So, and making those interesting, beautiful photos of the glow around different objects, like you see on the screen, leaves and hands, etc., etc. So, but it was more like a game. It was more just for fun and for just for curiosity, you know. No special information could be taken from these photos. Well, they are beautiful, right? It is like that. Not many people were really understanding what kind of glow it is and what to do with it. So beautiful pictures. That's it. And then Peter Mandel from Germany, who have been playing with this and making lots of research himself with the photos of fingers and toes, he has devised his own equipment. So it's still being constructed nowadays. And I know that there's still some users in Europe, first of all, who are using Peter Mandel's devices, even though they're using just photographic plates, photographic film, but still people are doing it. It's not digitized, it's just manually made. But his good idea was that he has proposed to apply acupuncture point concept to the pictures of the glow of hands, of fingers and toes. So he has overlaid the acupuncture point concept taken from Sujok, South Korean system, onto the images, and beginning from that moment, he has tried to do some interpretation according to these acupuncture points. So he was relating different parts of the images that he was obtaining with these acupuncture points, and then making the interpretation of the energy state of the person. So, and well, the first diagnostic table has appeared. Well, diagnostic meaning that the pictures of each finger and each toe were divided into sectors, and each sector was connected with some specific organ or system in the body according to the acupuncture point concept of Sujok. Well, only 3 years later in Brazil, the device by Newton Milhomens has been approved as a Brazilian official standard of Kirlianography. So, and lots of researchers were using it and in their practices too, and also trying to make some interpretation of the data. But you know, it was still based on manual reproduction of the images. So, end of 20th century, beginning of the computerization and digitalization of everything in our lives. The computers were available for the general public, and in 1995-96, a group of scientists that were led by Konstantin Korotkov in St. Petersburg, Russia, they have made a huge step forward in Kirlianography. So instead of doing everything manually, photographing it on a photographic film or plate, they have created a digital device that was computerized. So the photograph of the emission of this glow was captured by the CCD matrix, coupled charge device, the video camera, in other words. And this digital image was processed by the computer. So the software has appeared that was able to process the digital Kirlian images. And nowadays, he's Professor Korotkov and doctor in technical sciences. He has proposed a new name for this method, not Kirlianography, but gas discharge visualization. So because the device was visualizing, photographing the gas discharge or air discharge. So you know that science is based on statistics. And of course, without statistics, without reproducibility, you cannot study anything properly. So thanks to appearance of this equipment, GDV camera, well, some models one of the first models you can see on the screen right now. Researchers and therapists were able to capture several times the glow or capture fingers several times in a row and see reproducibility of the data. It has allowed and made it possible to do the calibration of the device, so to have some kind of reproducibility and to compare the results between them, between each other, and to develop some kind of norms. So, and of course, this has become super popular worldwide, even though it was very expensive equipment. So one device with software could cost 10 or 15 or some, or even more thousand of dollars, euro. Still, people were so interested in studying this unknown phenomena about this glow around the human fingers, and people were still thinking and curious that it is some kind of aura that these devices able to capture. So people started doing scientific research. The software has applied the Peter Mandel table of intersection of the sectors on every finger, and henceforth they were doing the software was helping to do some interpretation of every sector and every finger, and then making some kind of correlation studies to compare the data from the GDV camera with different other methods of studying the human state. So it was very good, but still Dr. Korotkov was not satisfied enough because not many people were able to obtain this device. Because it was super expensive, it was constructed in St. Petersburg one by one, so very expensive. And his dream was to create a device that will be affordable for every family. So a big step forward was made in 2014 when Biowell device has appeared, that you can see on the screen. And the software, as long as it is constantly being developed, it was moved to a server. So every user of the Biowell device has own account where all the database is saved, and the only thing people need to do is to have the device, have the subscription to the software, and they can do their own research with lots of parameters that we will discuss later on during this lecture. So the price of these devices several times less than of the previous GDV devices constructed by Dr. Korotkov and companies that he has created. So, and this has given a big boost to the development of the GDV technology and Kirlianography. So nowadays, several thousands of users are implementing this technology and BioWell device in their practice. And we will discuss in more details what it's all about, what exactly we are capturing, why so many people are interested in that. And also, just because it's not an easy effect from the physical point of view to understand, still many people are doubting, is it really measuring what we're saying? Is it really aura that we are measuring, or it's something else? I will clear all the doubts and answer all the questions about the physics of this process later on. So let's move forward. Physical principles of GDV, gas discharge visualization. Well, if you consider the history that we have just discussed, you will understand that there were a lot of confusions around these topics. And people were not really understanding what actually they are photographing and what Kirlian photography is about. So in the beginning, well, end of 80th, then 19th century, when there was no proper quantum physics understanding, of course, they were not able to understand what's going on there. In 20th century, with the development of quantum physics and understanding the processes that are going on those atom molecular level, people were able to understand better. But still, even now in 21st century, lots of people, when they're seeing the Kirlian photography, say, "Oh, please photograph my aura." But aura has no strict scientific definition. What is it? There's no such term that will describe what kind of it. Yes, this is glow, but what kind of glow? And just because of this lack of knowledge, and even nowadays, not many people really understand quantum physics in order to understand what's going on in Kirlian effect. So they prefer to think that this is some kind of esoteric stuff that is being measured by GDV. It's not true. And I will try my best to explain it in layman terms, in a pretty simple way, the physics of this technology. So there are two names of this technology. The most widely used, widespread, is gas discharge visualization, or simply GDV. There is another name, electrophotonic imaging. It's also being used in some literature, in some publications. So now we need to learn the definition. And the essence of these technologies in this definition, I know that it will be a little bit complicated for you to understand it from the first try. That's not a problem. I will explain on the words used in this definition later on. So, GDV or EPI is an analysis based on capturing, photographing, the photonic emission stimulated by the flow of electrons that is created by a high voltage, high intensity electromagnetic impulse, and also high frequency. So the essence of this definition is in word stimulated. So it means that this kind of photonic emission, this glow, is not something that we constantly walk with, like people call aura. No, this emission that we get is stimulated. It means we are extracting it. So how this process is going on? Step by step, let's discuss it. So, when the high voltage is being applied and there is a big difference in electrical potentials between the object, well, like your hand or metal cylinder that is used with the Bioel devices, the electrons get attracted by this high voltage, high electrical potential on underneath the glass electrode on which the person puts the finger or the metal cylinder. And because of this difference in potentials, the electrons are flying away from the surface and the electronic flow is being created. Then these electrons collide with the air gas molecules, excite it, and the air molecules emit light. Our devices, Bioel devices, and all other Kirlian photography, GDV devices, are photographing this light. Let's try to talk about each step in more details. So this is the principal scheme of the GDV device. So you can see here the object. Well, in this case, it is a finger, but it can be any other conductive object, metal cylinder, calibrator too. So there is a glass electrode, this transparent dielectric plate, but on the bottom surface of the dielectric plate, you can see here, it's the black line underneath it is the transparent electrode. So there's a transparent conductive layer underneath the glass to which the high voltage impulses are being sent by the electromagnetic impulse generator that is inside the GDV device. The glow that is being created in the air is being photographed by the video camera and then transferred as a digital image to the computer. So the first step, the first effect that we need to talk about is called field electron emission, also known as simply field emission or electron field emission, etc. So this process happens when there is a big, strong electric field applied to some conductive object. Just because of this strong electric field, it attracts the electrons from the material, from this conductive object. And it doesn't matter if it's your finger or it's a piece of metal. They're both conductive. That means in both cases, electrons can be extracted from there. So electrons are attracted by this strong or high intensity electromagnetic field. And they fly out to the air. What happens next? These electrons, just because they're flying very fast, they collide with the air molecules. And as you can see on these two schemes, after this collision, the electron continues its flight, but it takes out one electron from the molecule and one proton from molecule that fly further away. Then they strike next molecule again, creating more free electrons in the air and more positively charged ions in the air. And as you can see on the second scheme, this Same process is going on in the opposite direction, where the positively charged ions are flying towards the negatively charged electrode. So just because of the flow in the opposite directions of the negatively charged ions and positively charged ions, like electrons and protons, the electric current appears in the air, so-called electronic avalanche. So that is also can be seen as coronal discharges because just because of few electrons appearing in the air, they multiply very fast with very high speed and create lots of free electrons in the air. So this process of creation of electronic avalanche is also connected with the next process. So this flow of free electrons in the air, as long as it is not simply vacuum, it is air in which we are making GDV images. The air molecules absorb some of the energy that electrons transfer to them, and they go to the excited energy state. So they increase their energy state. And just because of this increase in energy and due to the laws of the quantum physics, it's not a normal state for this molecule, and it cannot stay at this energy level for a long time. So after some time, it relaxes back to the ground state, initial state of energy, and the excess of energy is emitted in the form of light. So exactly this light we can see on the images in GDV. So that's why you can hear and you can see this kind of glow, and you can hear sound during the gas discharge. Sound is just because this electronic avalanche is propagating through the air with very high speed, and we hear these vibrations as a sound, cracking sound. And also we see this beautiful light emission. So this light emission is not of the material itself, it's more of the air. And we are photographing this light emission. And we get these kind of beautiful photos. You can see that the colors of the light are light blue, blue, violet, but biggest part of this corona discharge is in ultraviolet spectrum. So it means we cannot see this part by our own eyes. We need to use ultraviolet video cameras in order to register this ultraviolet emission. But it's too expensive to integrate such ultraviolet sensitive cameras into GDV equipment. That's why we are photographing only visible part of the spectrum. So only that part that can be seen by your eyes is photographed by the Biowell GDV device and other GDV devices. It's in the same spectrum that you see on this picture. Light blue, blue, violet, and the high intensity is seen by us as just white color. As long as we are not applying so much of electricity, I mean, the voltage is not as big as is being used for different Tesla coils and likewise, like devices. In GDV devices, the level of voltage, for example, in Biowell, is used somewhere between 3000 volts to 5000 volts. In average, normal device will work with 3500 volts. So 3 kilovolts is not as much as being usually used in Tesla devices. In Tesla devices, it's 10,000, 20,000 volts. So, and you can see that because the intensity and the power that we're using is not so big, you will not see bright light, white colors here. You will see that it's mostly blue, slightly violet, and again, biggest part of the emission is in ultraviolet part of the spectrum that we cannot see with our eyes and is not registered by the equipment, bioelectrography equipment. Well, now that we know the physics behind this, we understand that we are photographing not some kind of aura around our body, and we are photographing the corona discharge. And corona discharge is created, and this glow is created by the air that is created by the electronic flow from the material, from the object that is being studied. And again, doesn't matter if it's your finger that's also conducted, or some kind of metal cylinder, or any other material that you want to study. So the figures that you see inside these beautiful pictures in Biowell software has nothing to do with aura. This is just beautiful computerized redistribution taken from 10 scanned fingers. Figure of the body inside these pictures are just beautiful representation. It doesn't mean that this emission is coming from your legs or from your feet or from your arms, etc. No, it has nothing to do with legs, etc. So we will talk about these sectors, and I will show in the software how it really looks like, how this image is being formed. So colors that you see here are also artificial colors. So this coloring is made by the software. It's not the real colors of the emission of the glow that we are photographing. So the image with which the Biowell or other GDV software is working is actually grayscale. So it works with like black and white. There are no other colors there. So absolutely black pixel is 0 intensity. Absolutely white pixel is 255 intensity in relative units. That's it. No colors there. Coloring is made in the software, and I will show you later how it is being done. So let's talk about the human fingers. What is really special about capturing the human fingers? And what's the difference between capturing the finger and capturing some inanimate conductive object? So we have a digital image, like you see on this screen in a grayscale mode. Each digital image has pixels. In case of the Biowell, the size of the image is 370 on 285 pixels. Fixed. It's always like that. It's always 370 on 285. So there, as long as these are pixels, every pixel has its intensity that you can see. It's measured in relative units, where black is 0, white is 255. So there's like 256 grades. Area is just number of pixels. So if you take the calculator and calculate 370 times 285, you will get 105,450 pixels. So this is the standard number of pixels in the software, in the images that you get. But of course, you are not interested in all these background black pixels or even gray pixels. You're interested in only those pixels that are connected with the glow of the finger or any other object that you are studying. So in our software, we have the area parameter. An area parameter is taking into consideration only those pixels that are not black and that are connected with the glow from the object under study. So you see that there are two main parameters called area, so number of the pixels in the image, meaning only the glow pixels, and intensity of these pixels. And of course, if you multiply them on each other, the intensity on the area, you can get the third parameter that is widely used in Biowell software, that is called energy. Of course, to transform these relative units to joules energy, we need to use some specific correction coefficient that is transferring from the joules of the absorbed light to these relative units of intensity, so that we know that if the pixel is 200 relative units, it means this amount of joules of absorbed light. So of course, as long as this light is in quantums, in photons, this photonic emission, as long as we know approximately the wavelength, and it's around 300 nanometers, so like violet part of the spectrum, so we can more or less understand and make a calculation of each pixel and transfer these relative units of the digital format into joules of the absorbed light. So in the software, we use the joules parameter in many subprograms. But remember, these joules are the joules of the absorbed light. It's not the joules of the person being studied. It's not the joules or energy of the object being studied. No, this is energy of the absorbed by the video camera CCD matrix light. Let's continue and go to the Biowell software in order to look in real time how the processing of the digital image, GDV image, is being made inside the software. You can see on the screen the standard representation of the captured images in the Biowell software. So you see these colored images in front of you. Whilst it's not the raw image, it's not the raw data, it's already processed data. On these images, you will see the sectors and the blue, red, violet, orange colors. But the actual initial image looks like this. And as you can see, there is no gray pixels on the background. So the background is absolutely black. This is specifically made by our software by clearing the noise pixels that are not needed for our processing. So only the pixels that are connected with the actual finger are being left on the image. Everything else stays absolutely black. So the colors that you see in the software that looks like this are made by the software based on the spectrum of the emission. So if you look at the spectrum of this picture, you will see this kind of graph. So from 0 to 255, it's intensity on the x-axis, and from 0 to unlimited number, actually, the count, the pixel count, number of pixels of this specific intensity. So for example, we can point on any intensity, and on the right side of the screen, we will see the number of pixels of such intensity. So for example, in this case, there is intensity 61, and there are 93 pixels of this intensity on the image that we're looking at. This image and this spectrum is innate for Bioweld 1, whilst the Bioweld 2.0 device has different spectrum. So see, it has these breakthroughs. So you can see that the biggest number of pixels, 280 pixels, are of intensity 40. So it means these low intensity pixels, the biggest number of them is here at the edge of the image and inside of the finger. And as you can see, the initial part of the spectrum is blank. Almost there are no pixels. It seems that there are no pixels there. Whilst it's not true, there were pixels there, but at the moment the image was saved on our Bioweld server, all these pixels that were here inside close to black were deleted from the spectrum. So the spectrum was cut, and you can see here it was cut here at intensity 38. So all the pixels that were below are absent. So they are not included into the calculation of any parameters in the software. So if you look at any image of a finger or metal cylinder, you'll see that there is like inscribed ellipse. So this contour inside of the image. And of course, as long as our finger, for example, is slightly transparent, of course, some amount of light gets inside through the skin into the inner part of the image. So you can see that there are some pixels inside the circle ellipse that is surrounding the image of the finger. And it's normal just because your finger is transparent. If you take the metal cylinder, you will not see as many noise pixels inside. Let me show you an example. Here you can see that there are almost 0 noise pixels inside, just because the metal surface is not transparent and doesn't allow some of the light, refracted light, to get inside of it. It reflects everything. Whilst our skin is not like that, it allows some amount of light to get through it inside. So if you look at it, you will see that there are 2 contours. One contour is inside this ellipse. In this case, it's circular because it's the calibration cylinder image. And there is a blue line surrounding the image outside. This is an external contour. So 2 contours, inner one and external one. And the difference between them is the thickness of the glow. So if you calculate it from the center of this image, then you can know how many pixels are thick this glow. So, and you can easily see it on this diagram here, where you can see from 0 to 360, it's the degrees from 0 to 360 all around this circle. And then there are 3 graphs: the inner contour, the outer contour. The inner contour is blue. As long as it is a circle of the metal cylinder, it's almost ideal straight line. So the radius of this circle is stable. There are just 1-2 pixels deviation, just because with this it's impossible to draw an ideal circle with squares pixels. Then you can see the red line is showing you the external contour of the glow. And if you extract the inner contour from the external contour, you will get the glow width. This is this black graph at the bottom. And you can see clearly that it's also very stable, linear, same thickness of the glow all around the metal cylinder. And of course, when you work with fingers, it's not so uniform. If you go to isoline, you will see that the blue line is not straight, because it's very hard to put the finger in such a way that it will be circular in the shape. And of course, the emission is not the same width. So you see that in some cases, there are even gaps in the emission, so the glow width is 0, whilst in some places it's closer to like 25, 26 pixels, whilst in some places it's closer to 10 pixels. So it's not uniform as with a metal cylinder. So these are the main parameters in our software that you need to take into consideration. Well, if you look at the colors, you can see this palette here at the bottom, whilst in parallel with the grayscale pattern, palette that is going here from black, 0 intensity, to 255 maximum intensity, white color of the pixel. You can see that there are colors assigned to every intensity of the pixel. And the width of each color is not the same, because the same is only the number of pixels of this color. So you see how wide is the light blue color here, but the number of pixels of this intensity is the same as here of this color. And of course, you can see that the orange is very narrow, and it takes also only colors 36, 37, 38, 39, 40, 41, and 42 intensity. Why? Because there's big amount of pixels of this intensity. So in the way that we color it is that it is equal amount of pixels of each color. So if you look here, you will see that number of light blue pixels is the same as the number of orange pixels, is the same as the number of red pixels, etc. So that's how we are coloring these images. Whilst again, initial image looks like this, grayscale. So let's continue with comparison of the image of the finger and the image of the cylinder, and understanding why there is some difference between them, why you see some gaps and irregularities in case of the fingers, and you don't see such irregularities in case of the metal cylinder. Once again, our main parameters in the processing of the digital image are area and intensity, and indirectly calculated parameter energy, area times intensity times specific correction coefficient for biowell devices. That gives us energy of the absorbed light. So what we are actually measuring? So it means that we are measuring the absorbed energy of light. But why do we get more light or less light from the object placed on the glass electrode of the biowell device or any other GDV device? Here you can see the graph showing that the number of pixels that you get from on the image from the gas discharge depends on the capacitance, electrical capacitance of the object. It means that we're applying each time. You can see these squares on the graph. Each time the voltage in the GDV device was the same. So the amount of pixels, the area was increasing not because we were increasing the voltage of the device, but because we were increasing the capacitance of the object that is placed on the surface of the GDV device. Higher is the capacitance of this object, higher is the area of the glow. Same graph can be shown for intensity. So higher is the capacitance, higher is the average intensity of the glow. So it means that the energy of the glow also depends in the same way. But what is the capacitance of this conductive object or finger or any other object? It depends on the chemical and physical properties of the object. What is the chemical composition? What are the physical properties of this object? All of these things are affecting the capacitance, electrical capacitance. But when we look at the images of the cylinder and when we look at the image of the finger, we can see that the image of the cylinder is uniform all around it. Same thickness, same structure of light, same intensity, same energy. And it doesn't matter which sector we take. Whilst when we measure the finger, it's not uniform anymore. It's different. And more than that, if you capture the same finger several times in a row, the emission will look different. Whilst if you measure the metal cylinder, as many times you measure, the result will be the same. Well, there is only one case when you can see irregularities in the emission of the metal cylinder. As long as you are going to be an expert in GDV technology, in biowell and biophotonics, you need to understand that the glow that we get on the biowell device depends not only on the object that is placed, but also on the environmental conditions. And of course, as long as it is photography, we are dependent on the properties of the surface of the glass on which the cylinder is being placed. So if there is any dirt or excessive humidity on the surface of the glass where you put the cylinder, then you can have irregularities in the emission of the cylinder too. So please remember this when you're working with the GDV equipment, that as long as this is still Kirlian photography, it means that the surface of your photo camera should be clean from any dirt and excessive humidity. Then the images will be stable and reproducible. So whenever you see irregularities of the metal cylinder, first of all, what you need to make is to clean the surface of the metal cylinder and clean the surface of the Bioweld device or any other GDV device if you're using other models. So first of all, you need to use alcohol that will dissolve anything that can be on the surface. We don't recommend to use any other screen cleaners or optics cleaners because they usually leave thin films on the surface of the glass optics. So we recommend to use alcohol or alcohol containing wipes that you can buy in any pharmacy store. But let's return back to the fingers. So why does the electronic flow from the finger is not uniform the same way as from the metal cylinder? So maybe it is connected with the properties of the fingertip itself. So it means the chemical and physical properties of the fingertip are not the same in every point of the finger. But why it is like that? Why do we have these irregularities? The answer is pretty simple. Whilst in the beginning of the development of this technology, it wasn't as simple as it seems to us so many years after that. Thanks to Peter Mandel, who has proposed first on this planet to use the Sujok meridian system, acupuncture point system, when making interpretation of the glow of the fingers. Now we understand that the glow in a specific sector of each of these 10 fingers is related to the acupuncture point that is in this place of the finger. So it means that the emission from the specific sector on each finger depends on the state of this specific acupuncture point. And this specific acupuncture point is somehow connected with this energetic state of some organ or system in the body. So that's why the emission is not the same in different parts of the glow of the finger. And you can easily find excessive emission in one part and absolutely no emission in another part. Additionally, of course, our fingers are constantly sweating or emitting some vapors or emitting fat and sweat, etc. And these things are also are affecting the glow, the corona discharge. So they change the structure of the emission too. So it means that the electrical capacitance that we were discussing earlier is not uniform in the finger. It's different in different points. And that's why the emission from these points is also different. Now let's talk about different GDV devices and different GDV equipment available at the present moment on the market. And I can say that according to the history that I've told you about the development of the Kirlian photography and GDV technology, of course, these different types of devices by Professor Newton Milhomans are still being sold in Brazil, and you can buy them. There are different copies of these models also available. Different other researchers has created their own Kirlian photography or GDV devices, and they are trying also to sell them. Peter Mandel devices are still there, and still there are some people who are using them, And even though they're not digital, so they cannot be called a GDV device, they're still a Kirlian photography made manually. The devices that were designed by Professor Kortkov initially in 1995, the GDV camera, GDV compact that were created in St. Petersburg, Russia, are still on the market, even though they're super expensive in comparison with the BioWell, they're still there. There are different other copies of the GDV devices invented by Dr. Kortkov and his colleagues. The most profound in terms of the technology of the hardware and the software is the BioWell device and BioWell software. That is the most widely spread in the GDV world, all around this planet. There are tens of distributors worldwide selling these devices and thousands of users. So let's take a closer look on the actual equipment and what kind of GDV devices and accessories are available at the present moment. So let's go just to the official website of the BioWell company and take a look at the products that are available there. Let's go to the official website of the BioWell company and take a look at the products that are available there. So beside the BioWell device, the current model is BioWell 2.0, and well, those people who have bought BioWell 1.0 years ago have the possibility to upgrade it. There are different accessories. Sputnik accessory is a special sensor that can be connected to the BioWell device in order to make the comparative or relative studies of the environment, energy, space energy in real time during different meditations, different events, theatrical performances, etc. Or to study some geopathic zones, etc. There will be lectures devoted specifically to Sputnik and the work with it. There is a BioWell glove that is a conductive glove that can be worn on the hand and connected to the BioWell device to measure the state of the hand and henceforth the whole person during a long-term experiment, like for example during meditation or during like watching some theatrical performance or movie, etc. So can be used in real time, and we will talk about usage of these accessories during the lectures on this course in the university. There is a water sensor that can be put into the bottle of water, and for example, if you do a non-chemical influence on this bottle with water or some other conductive liquid, the water sensor can show you if there is or there is no change in this liquid. So they're not actually, neither Sputnik, neither glove, neither water sensor, they're not a measurement tools. They don't actually give you an absolute value of some specific parameter like conductivity or electrical capacitance, but they can be used for relative measurements like before, after effect. And we will discuss this during specifically devoted lectures to these topics. There is also a BioCore device. This is a special accessory that is able to process the chakra music that is created in the BioWell software based on the full scan. And then using the specific music that is created accordingly to the energetic state of the person. This device, together with the extremely high frequency emitter, can help the person to relax and de-stress and harmonize himself or herself. And of course, you can scan with the BioWell before and after to see the effect of the BioWell. There are filters in order to measure people who are super stressed and for whom the fingers are super sweaty, and you cannot get any reading without filters. But of course, the main product is the BioWell device. Of course, the device has the AMC electromagnetic compatibility certification, EU certification, UL certification, but the thing is that it is not a medical device. BioWell is not certified as a medical tool and is not intended to somehow analyze, diagnose, or heal some ailments or health disorders. BioWell is made to assess three things: stress, energy, and balance. Neither of these three parameters are medical, so the device is not a medical tool. It's a wellness device. And you can monitor your stress, energy, and balance through the time before and after different types of therapies or different other impacts that you can apply on the person, and compare the result between before and after. So it is safe. So it has all the certifications stating that it's absolutely safe to use it. As we have discussed the physics today, the impulse of those 3.5 kilovolts is super short. It's only several microseconds. So it means that you will not feel anything when you touch the glass of the device of this device and you get the impulse. But this time is enough to extract the electrons from your fingertips and then analyze the glow from the air. The frequency with which the impulse is being applied. So it's not a one impulse, it's a batch of impulses with 1000 hertz frequency, but within only like several microseconds time length. So these technical parameters are allowing us to make the scan of the person with almost zero effect on the human being. So the person who is being scanned doesn't feel anything. The only thing that you can hear is the sound beep of this gas discharge, corona discharge that is happening in the air, nothing else. So it's absolutely safe. It is certified and ready to use, and you can see that we have pretty high and big chain of users and professionals worldwide. So let's talk a little bit about our community. So as you can see at the top bar of the website, we have different other networks connected. So you can go to the BioWell Company official YouTube channel, where we post our training videos, where we post the recordings of the interviews or some congresses that we held, or other interesting educational information. So you can find playlists that are devoted to the Science Information Spirit Congress. You can find the playlists connected with the interviews taken from prominent lecturers, professionals, professors or doctors worldwide, like Nato Pignataro from Brazil, Michael Borkin from United States, Tiffany Barsotti, Elizabeth Donvier from Germany, Krishna Madappa from India, Victor Hugo Arguelles Mora from Mexico, Avinash Kulkarni from India, etc. Very interesting lectures that you can watch there. So welcome, join our YouTube channel and watch our training videos. Their basic level course is also published here, where you can see the basic video, the basic training pre-recorded by Dr. Korotkov, and some other videos. For example, last year in 2020, we made webinars about interpretation. So you can find this interpretation webinars by Dr. Korotkov, by Well in Research. You can also watch my seminar about Biowell interpretation that was made 1 year ago. So all of these things are available here. Please join our community. It's constantly growing. Even though we have just started this channel 1 year ago and not so many people has joined for now. We have our official Facebook group, the Biowell Worldwide group, where we post our news and information for the users and for other people who are interested. Just there are several thousand followers there. Just join the community there. We're constantly publishing some interesting information there. Besides that, we have a Biowell official group. So in the page, of course, you don't have the right as a participant to publish anything there. But in the group, it's possible to publish information about your equipment, about the results that you get, about some questions and answers about this. We inform about upcoming seminars there, and we discuss just interesting topics also. Well, you're welcome to join and to discuss some interesting things that you have in your mind. Ask the questions, and you can discuss within our community of the professionals in this field. Welcome. We have also an Biowell company Instagram, so where we also share the news and some photos from the trips by Professor Korotkov worldwide about some new research that is being made on new publications, new software developments, etc. So please find the Biowell company Instagram and follow us. We have the additional website beside the official biowell.com website, where all the official information is available, where you can find the manuals for the equipment. And of course, if you are using Biowell or any other accessories, you have to visit this page and download the manuals from here. Beside that, we have a website, EUMAB website, International Union of Medical and Applied Bioelectrography, where we publish all the papers from all the spheres, even from medical spheres of application of the Biowell. And you can find the publications here, a big archive of publications in different languages from different authors within the last years. So you just select the topic, you select the author or language you want to search, and go for it. There are hundreds of papers here, very interesting to study. If you really want to become an expert in this field, you have to read it. There are even some books published here, so welcome. Download them for free. Just click the view and you will get the PDF version. Another resource that I want to share is the Science Information Spirit website, siscongress.com or .ru. It's the Congress that is being held for 25 years in a row, and where on this website we are publishing all the information about the upcoming Congress, and we are also giving the information about the speakers of the Congress who will be presenting there. So you can see authors, the speakers who are giving the course exactly here in the university course too. And also you can have a look at the archive of the Congress that is going up till 1998. So you see that there it was abstracts only in Russian since 1999, or abstracts in English and Russian too, photographs from there and presentations and even videos. As you have seen, we have videos recorded. The whole Congress was pre-recorded last 2 years for sure, and they're available on our YouTube channel. So you can register for this Congress in 2021 or any next year. This year it's absolutely free. It's going to be online Congress. So welcome. Follow this Congress. It's being held every year in the summer. All the information is available on this website. Beside that, we have a Telegram channel that was just created not so long ago in order to have a separate platform for communication with our clients and users, where we discuss different things and we post the news, and people can also have the ability to ask the questions, and you're welcome to join our Biowell company chat, follow us there, and ask your questions if you have some. So another thing is that we have a big network of authorized distributors, so representatives worldwide. You can see on the map these flowers with the D letter. These are our authorized distributors worldwide. So it's constantly growing network. We are growing every year, and new distributors are coming, and you can find one who is working in your area where you live, and also contact them and ask them questions or come for a live demonstration. But besides the distributors, there are also practitioners. There is, well, only some part of them are on the map, but of course, much more there available. So we put on the map only those who have given us their written consent and that they want to be present on this map. But in the reality, there are much more users worldwide than you can see on this map. You can find the one in your area and contact them too, and maybe have some demonstration, or you can make some collaboration with them. Also, in order to pass the training on the Biowell technology, of course, it's not enough just to watch the videos and to read the theory and manuals in the written form. Of course, it's very, very useful to pass the trainings. And for these purposes, we have authorized Biowell trainers worldwide that are present on this list, on this page, trainers page on the Biowell website. So these are the trainers who are authorized to give advanced level trainings, where you, beside the theory, you can have the practice together with them under their guidance. So almost in every part of the world, there are our representatives who can speak your language and who can give the training for you. So again, if you will be interested in getting specific training by one of these trainers, you're welcome to contact them. and have a training with them. And also, maybe you will become one of our trainers someday. Just once you will finish this course, you will feel yourself a good expert, and then you will pass the test to become a biowell expert, and then to become a trainer and teach others this technology. So I want to thank you all for watching this lecture, and for taking this course. Thank you very much for your attention. You can find my contacts on this page, and if you will have questions regarding the lectures that I'm reading, I am open to any questions, and I will try to answer them all. So thank you very much for watching this video, for listening to this lecture, and I wish you all the best in this education and passing all the tests, and see you on the next lecture. Bye bye.